if a first task can be performed in m ways, and the two tasks cannot be performed simultaneously, then performing either task can be accomplished in any one of m plus n ways. A library has 40 textbooks in sociology and 15 mathematics. How many ways a student can select one book? There are 40 plus 50 is equal to 90 choices. This is the last class discussion. Now we are going to try to solve more problems. Suppose a university representative is, suppose a university representative, question kuda ezhudikolle, question kuda ezhudikko. Suppose a university representative is to be chosen, question kuda ezhudippo, either from either from 200 teaching or 300 non-teaching employees and then there are how many possible, then there are how many possible ways to choose one representative. Suppose there are 200 teaching and 300 non-teaching employees, then there are how many possible ways to choose one representative? How many possible ways? What is the answer? By rule of sum, there are first 200, second 500, there are 200 plus, by rule of sum, there are 200 plus 300. There are 200 plus 300 is equal to 500 possible ways. 500 choices ഉണ്ട് അല്ലേ, 500 possible ways to choose this representative. Next, extension of sum rule. നമ്മുടെ സം റൂൾ പറഞ്ഞത് ഒരു കാര്യം first task can be first task can be performed m ways, second task can be n ways. This task cannot be performed simultaneously, then performing either task can be accomplished in any one of m plus n ways. Here there are a number of more than 2 tasks, first, second, third, fourth, etc. If task T1, T2, T3, etc., Tm can be done in N1, N2, N3, etc., Nm ways, and no 2 of these tasks can be performed at the same time, then the number of ways to do one of these tasks is extension of sum rule. Last case discussed for only 2. Now we generalize for M cases, if tasks note notebook if tasks T1, T2, etc. Tm can be done in N1, N2, etc. Nm ways respectively, and no two of these tasks and no two of these tasks can be performed at the same time, then the number of ways to do one of these tasks in N1 plus N2 plus etc. plus number of ways to do one of these tasks in N1 plus M2 plus etc. plus Mn ways. This is the generalization. The sum rule is for 2 and this is for M cases. Now a problem: if a student, question kuda ezhudi pakko, if a student can choose a project either 20 from maths or 35 from computer science or 15 from sociology, then in how many ways a student can choose a project? How many ways a student can choose a project? How many ways a student can choose a project? That is, there are 3 tasks. First case is for 20, second case is for 30, and third case is for 15 by the by the extension of some rule, there are 20 plus 35 plus 15 is the answer. The student can choose. The student can choose a project in. A student can choose a project in 20 plus 35 plus 15 is equal to 70 ways. Next, the rule of product. Rule of product. Next, the rule of product. Rule of product. Suppose we suppose there are 12 maths book and 5 physics books. We want to choose 2 books. We want to choose 2 books. One is maths and other is physics. Compulsory. Then how many choices are there? So for a simple question, suppose there are 4 maths books and 3 physics books. We want to choose 2 books. One is maths and the other is physics. There are M1, M2, M3, M4. These are maths books. P1, P2, P3 are physics books. Then the choices are, we want to choose 2. The choices are M1, P1, M2, P2, M3, M1, P1, M1, P2, M1, P3, M2, P1, M2, P2, M2, P3, M3, P1, M3, P2, M3, P3, M4, P1, M4, P2, M4, P3. How many choices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is 3 into 4, 12 choices. That is the rule of product. This is the example. The rule of product is, if a procedure can be broken down into first and second stages, if a procedure can be broken down into first and second stages, and if there are m possible outcomes, and if there are m possible outcomes, and if there are m possible outcomes for the first stage, and if for each of these outcomes, and if for each of these outcomes, and for each of these outcomes, and if for each of these outcomes there are n possible outcomes for the second stage, there are n possible outcomes for the second stage, comma, then the total procedure can be, carried, then the total procedure can be carried out in the designated order in m into n ways. Like the last example, there are 4 maths books and 3 physics books. Each one of the mathematics books, there are 3 physics books choices. So first maths book has 3 physics P1, P2, P3. Second maths book has 3 P1, P2, P3, 3 choices, like 5. So 4 into 3, 12. Total 12 choices. For one, we want to choose 1 physics and 1 maths. There are 4 maths books and 3 physics books. We want to choose 2 books. One is maths and other is physics. There are 4 into 3, 12 choices. Like, if a procedure can be broken down into first and second stages, and if there are m possible outcomes for the first stage, and if for each of these outcomes there are n possible outcomes for the second stage, then the total procedure can be carried out in the designated order in m into n ways. In m into n ways. In m into n ways. M into n ways. Okay, this is the rule of product. Question. In a drama club, there are 6 men and 8 women, playing for the leading male and female roles. How many ways? Then how many ways the director can select? The director can select a couple. There are 8 men, 8 women and 6 men. How many ways a director can select a couple? That is, we want to choose 2. One is men. We want to choose 2. One is men and the other is women. Then how many? possible selections are there. There are, by the rule of product, there are 6 into 8, 48 possible selection. That is the answer. By the rule of product, by the rule of product, by the rule of product, the director can select, the director can select a couple in 6 into 8 is equal to 48 ways. Next important question. A license plate, a license plate a license plate consisting of two letters followed by of two letters followed by 4 digits, followed by 4 digits. A license plate consisting of two letters followed by 4 digits. Then first sub question, if no letter or digit can be repeated, if no letter or no digit can be repeated, then how many before discussing this question, we write the general extension of product rule. Next we write extension of product rule, then we solve this problem. Extension of product rule. What is extension of, before writing the extension we do one more problem. A tourist can travel from Hyderabad to Tirupati in 4 ways. A tourist can travel from Hyderabad to Tirupati in 4 ways, either by plane or train or bus or taxi. He can then travel from Tirupati to Tirumala Hills in 5 ways. By road or bus or taxi or ropeway or motorcycle or walk. Any of the 5 ways. Then how many ways? Then how many ways a tourist how many ways a tourist can travel from Hyderabad to Tirumala Hills. There are first Hyderabad to Tirupati, then Tirupati to Tirumala, Hyderabad to Tirupati. There are four ways to, and Tirupati to Tirumala there are 5 ways. Hyderabad to Tirupati there are 4 ways, and Tirupati at each of these we can choose 5 selections. Each one have 5 selections. Each one have 5 selections. So there are how many choices? 4 into 5, 20 choices. So a tourist can select 20 ways to travel from Hyderabad to Tirumala. Answer is 20. Solution is by the rule of product. By the rule of product. By the rule of product, a tourist can select 4 into 5 is equal to 20 ways. 4 into 5 is equal to 20 ways to travel from Hyderabad to Tirumala. That is the answer. 20 is the answer. Next, extension of product rule. Extension of product rule. Suppose a procedure consists of performing tasks T1, T2, T3, etc. Tm in that order. Suppose task Ti can be performed in Ni ways after the tasks T1, T2, etc. Ti minus 1 are performed. Then the number of ways the procedure can be executed in, executed in the designated order executed in the designated order is equal to n1 into n2 into n3 into n4 into etc. nm. That is, here suppose a procedure can consist of performing task T1, T2, T3 etc. Tm in that order. Suppose T1 can be performed in n1 ways, T2 can be performed in n2 ways, T3 can be performed in n3 ways etc. T2 can be performed in n2 ways after T1 are performed. T3 can be performed in n3 ways after T2 is performed. T3 can be T4 can be performed in n4 ways after the task T3 are performed etc. That is the generalization of the product rule. So the number of ways the procedure can be executed in the designated order is n1 into n2 into n3 into etc. into nm. Question. Sharmas. Branch shirt available in in 12 colors has a male and female version, it comes in 4 sizes for each sex, in 4 sizes for each sex. Comes in 3 makes of economy, comes in 3 makes of economy, standard and luxury. Economy, standard and luxury. Then how many number of different types of shirts produced? Then how many types of shirts? How many different types of shirts? How many different types of shirts? How many different types of shirts produced? How many different types of shirts produced? What is the answer? What is the answer? Can anyone? A brand shirt available in 12 colors has male and female version. That is 12 colors. Male version and female version means there are 12 colors, male version and female version. It comes in four sizes. There are four sizes for men and four sizes for women. And makes of 3, that is 12 colors and 2 types for male and female. There are 4 sizes, 4 sizes for men and 4 sizes for women. And each of the 4 sizes, there are 3 types. There are 3 types. Each of the 4 sizes, there are economy, standard and luxury. So here 12, here 12, here 2, here 4 and last 3. So what is the number of different types of shirts? What is the total number of different types of shirts? How many different types of shirts are there? What is the final answer? 12 colors, then 2 types for male and female. So there are 12 into 2. Then 4 sizes. That is here for men for 4 size and women for 4 size. So 12 into 2 into 4. Then last 3. So our final answer is 12 into 2 into 4 into 3. This is the final answer. So the final answer is the number of different types of shirts by the extension of product rule. By the extension of product rule, there are 12 into 2 for male and female and 4 sizes into 3 classes, economy, standard and luxury. So 12 into 2 into 4 into 3. 24. 96 into 3. 96 into 3. 288. 288. There are 288 different types of shirts are produced. 288 different types of shirts are produced. This is the final answer. Next question. The manufacturer of license plates consisting of 2 letters followed by 4 digits. Like this: AB 1356, BC 4101, CD 1211, AS 1001. Like PQ 1112 etc. These types of number plates. This is the example. The manufacture of license plates consisting of 2 letters followed by 4 digits. First sub question is how many different license plates are there? How many different license plates? How many different license how many different license plates? How many different license plates are? How many different license plates if no letter or no digit can be repeated? If no letter or no digit can be repeated, how many different license plates if no letter or no digit can be repeated? Second sub question, how many different license plates? How many different license plates if repetitions of letters and digits allowed? Repetitions of letters and digits allowed. Number 3, how many different license plates? How many different license plates? How many different license plates if repetitions are allowed? If repetitions are allowed as in part 2, second part part 2 and have only vowels. How many of these plates have only? How many different license plates if repetitions are allowed as in part 2 and only vowels and even digits? Vowels and even digits. 0 is considered to be a even digit. The manufacture of license plates consisting of 2 letters followed by 4 digits. What is the answer? First question answer in the what is the answer of the first sub question? How many different license plates if no letter or digit can be repeated? How many letters and how many digits are there? We have A, B, C, etc. Z are letters. 0, 1, 2, etc. 9. So 26. There are 26 choices for letters and 10 choices for digits. There are 26 choices for letters and 10 choices for digits. So first sub question, how many different license plates? There are two letters followed by 4 digits. There are actually 1, 2, 3, 4, 5, 6. 6 places. This is the first place. This is the second place for letters. This is the first place. This is the second place. This is the third place. And this is the fourth place for digits. Here, first, how many different license plates? How many different license plates? That means no letter or no digit can be repeated. First we choose, there are 26 choices for first place for a letter, and actually there are 26 choices here, but we fix only one. There are 26 choices in first place, but we fix only one in first place. So there are remaining 25 choices in second place for a letter. So in second place there are 25 choices. So the letters is over. Now digits, first place. How many possible digits? There are 10 choices in first place. So 10 is the 10 choice. So we fix one of the 10. We fix only one here. Remaining 9. Then in second place for a digit there are 9 choices. So we fix anyone here. Only one in second place. Remaining 8 choices, that 8 can be filled in third place. So we fill only one in third place out of 8. Then remaining seven digits are there. So fourth place there are 7 choices. So by the extension rule of product, there are 26 into 25 into 10 into 9 into 8 into 7. This is the answer. Different possible plates are there. You understand? We have 26 choices. We have 26 choices for letters in first place, and 25 choices of letters in second place. Now 10 choices, 0 to 9, 10 choices in first digit, 10 choices for first digit, 10 choices for first digit, 9 choices for second digit, 9 choices for second digit, 8 choices for third digit, and 7 choices for last digit. Then by extension of product rule, there are 26 into 25 into 10 into 9 into 8 into 7 different possible. There are 26 into 25 into 10 into 9 into 8 into 7 is equal to 3276000 different possible plates, different possible license plates. Different possible this is the answer of the first question. First question is how many different license plates if no letter or digit can be repeated. Second, how many different license plates if repetitions of letters and repetitions of digits are allowed. For solving this, we have there are one first 4 letter, second 4 letter, this is 4 digits and digits and digits and digits. Here repetitions are allowed. That means like this Z 1 1 2 2, like A 0 0 1 2. If repetitions are allowed, then how many license plates are there? If repetitions are allowed, first case there are 26 choices, second case also 26 choices, digit is 10 choice, second is 10, 10 and 10, the final answer is 26 into 26 into 10 into 10 into 10 into 10. This is the answer. Here repetitions are allowed. Here repetitions are allowed. So there are 26 choices for first two, 26 choices for each of first two letters, and 10 choices for each one of 10 choices for each one of the following letters, each one of the following digits. So by the rule of product, thus by the rule of product, by the extension rule, so by the extension of product rule, there are 26 into 26 into 10 into 10 into 10 into 10 is equal to 6760000 different license plates are possible. Different possible license plates. Next, third, what is the question? How many different license plates if repetitions are allowed as in part 2, but only vowels and even digits? That means vowels, like example like this A, E, 2, 0, 4, 6. There are A, E, I, O, U. There are 1, 2, 3, 4, 5 vowels, and there are even digits 0, 2, 4, 6, 8. These are even digits 5 even digits and 5 vowels. So first two place there are 5 choices for each, and 1, 2, 3, 4 there are 5 choices for last 4 places. So there are 5 into 5 into 5 into 5 into 5 into 5 into 5. This is the final answer. So there are 5 choices in the first 2 places, and 5 even digits are 0, 2, 4, 6, 8 for each of the last 4 places. Each of the last 4 places. Hence, by the extension of product rule, there are first case 5, second case 5, third case 5, fourth case 5, fifth case 5, sixth case 5. 1 ഇത് രണ്ടും നമ്പേഴ്സ് ആണ്. ഇത് രണ്ടും ലെറ്റേഴ്സ് ആണ്. ഇത് 4 നമ്പേഴ്സ് ആണ്. So 5 raised to 6 choices. Different license plates. So it's a simple question. Now here the last fifth question is the application of both product rule and sum rule. A hotel offers 12 kinds of seats, 10 kinds of hot tiffins, 10 kinds of hot tiffins, and 5 kinds of beverages, and 5 kinds of beverages. Like beverages means hot tea, hot coffee, juice, coke, ice cream, etc. The breakfast can be consists of a sweet and a hot beverage, of a sweet here we more detail. What are the beverages? Beverages are hot tea, hot coffee, juice, coke, ice cream. Juice, coke, and ice cream. These are 5 beverages. The breakfast consists of
അടുത്ത ക്ലാസ് സമയമായി
ആണോ? ഒരു നിമിഷം ക്വസ്റ്റ്യൻ എഴുതിക്കോട്ടെ. അല്ലേ വേണ്ട. ഓക്കെ.